All right, what's up, everyone? We're back with another Polymath Salon today. This is actually on Alon's channel, not mine, the Ecolopto one. This is on Alon's channel. And we're going to be talking about, I suppose, how humans and LLMs are not truly so different at the end of the day. Maybe Alon wants to open with a quick summary about that whole thing for those who haven't heard it.
Sure, thanks, Addy, and it's kind of exciting. So, basically, what I've been doing for the past year or so is pursuing this idea that our own language, human language, is perfectly modeled by the underlying engine of large language models, meaning that that's the full account in terms of our language production, language generation. That when I'm talking now, what that is basically an LLM, and what you're listening with is essentially an LLM. Well, that gets a little more complicated when you talk about the receiving end. And so language, human language, is essentially modeled by the core engine of large language models. Now, without getting into granular details, I don't necessarily mean the exact way it's implemented, not even at a software level. It doesn't necessarily have to depend on the exact uh, specific algorithm as to how ChatGPT actually operates, but there's something fundamental. There's a couple of ideas as to what's fundamental. In a nutshell, the ideas are that it's self-generating, that the structure of language is what generates the next token, or it doesn't have to be the next token, but is what generates language. So that's the underlying structure itself, just relations between words, and that's what generates language. That it's autogenerative, meaning that you can actually extract the generative structure from sort of the static structure, the geometry of the language. And the second idea is that it's autoregressive, and that's how ChatGPT works. It's how a lot of the large language models work. And that's the idea that we are generating those tokens, these next words. We're doing it sort of autoregressively, meaning we generate one in response to a sequence, then tack it onto the sequence, and then use that new sequence with the next token, next word, as the input sequence. And so that we're doing it churning through one for all intents and purposes, we'll just call them words. It's technically a token, but basically what we're doing when we're speaking is we are generating one word at a time, and then using that to append it to the sequence that you've generated, and some memory, some residual kind of extra preservation of what you've generated before, and then use that in order to generate the next token. And that's how large language model like ChatGPT work. So what they're doing as you're having a conversation, they're just constantly taking the conversation until now, feeding it as an input, then actually predicting next token, and then take that, add it to the sequence, and then keep going. With a couple of special characters for things like, okay, I'm ending my statement here, or you just ended your statement, and things like that. So there's two basic claims that I'm making, and they are that language is autogenerative, meaning there's no room for other kinds of information. The only information needed to generate language is entirely contained within the structure, the geometric structure of the body of language. We think of that as the corpus. We can think of that as a spoken corpus if you're not thinking, in terms of digitized written language. But that's claim number one. Claim number two is that when we are doing generation from that corpus, from that sort of stored structure, we're doing it autoregressively. The second one is non-contingent, or rather, the first claim is not contingent on the second claim, meaning you can propose that language is autogenerative in this way, without saying it has to happen autoregressively. For example, diffusion models or some other kind of scheme could be used using, again, the same geometric structure of the body of language, but accessing it and leveraging it in a different way, computational way, to determine what the language generation should be. And one way to think about that is when autoregression says I'm generating the very next word. And that's what I'm doing as I'm talking. What ChatGPT does is literally just predicts the next token. But I could be thinking 5 tokens in advance and sort of actually working on a solution in parallel on the next token, and then the 5 tokens, or maybe the next sentence or something like that. And a diffusion model will do something closer to that. And so the second claim, which I'm still making this claim, is that what I mean by still is I'm not backing away from this claim. I think it's a very well supported claim. But the second claim is that we do this generation autoregressively, you can believe the first one and not believe the second one. But you can't do it the other way. You can't say, I think that language is entirely this autoregressive system that's doing next token prediction, because that necessarily implies that what you're doing is using that underlying structure. So I think as far as I've worked it out. So those are my two kind of claims that both are true fundamentally of the current crop of the most successful large language models. They are autogenerative and autoregressive. The autogenerative definition is something, I think that's a new term, but I think it's just descriptive. It's not really it's not any sort of novel claim. It's just basically defining a sort of a computational type. A sequence is autogenerative if it has these properties. I think it's true of language. I think it may be uniquely true of language, but there's a lot to say about that. But these are sort of the key claims are that it's autogenerative, that the structure is contained within the body of language, and I point to LLMs as basically proving that or demonstrating that it is true for at least a system that can generate language. My claim there is not that there's such a thing as autogenerativity, but that humans are similarly autogenerative, just as LLMs are. And then the second claim is that in order to leverage that autogenerative kind of structure, we do it autoregressively. Okay, so those are the main claims. I haven't really backed them up or anything, but that's sort of the overall essence. And another way of saying is that a much less long-winded way of saying that is the speaking me is an LLM, and is essentially the same thing as ChatGPT.
Amazing.
Humans are ChatGPT. There you have it, folks. That's it. Wrap up.
Okay, maybe I should have started with that because I've lost a lot of people by now.
You are an NPC.
Yes, we are all the NPCs. That's the true point of the story. So,
So
all
yeah,
right. So
who
I'm
exactly are the characters, and who are the playing characters? It's like that's maybe we're
well, we're
split.
all playing the characters.
We are.
This goes into sort of the idea of the stage and the actors, right?
So it's yes, well, so it's becomes you immediately run into this question like I'm talking now, right? If you just sort of accept this theory, just go with it. And I'm like, I'm talking now. Well, I no, that's the talking me that's talking now, and then there's me. I don't think that's not the entire system, right? There's this whole other stuff like my behavior, my physical movements, my perception. That's sort of a corollary of this whole theory is that the LLM is its autogenerative. It's its own informational engine. It does its own thing within this larger system, but there is a larger system, and so who's the me? And I'm hearing words and I'm hearing these talking words, but that's not necessarily even the LLM because there's a sensory system that's perceiving all and at the same time. But it's hearing words coming out of the LLM's quote unquote mouth because there's like an LLM chip that's sending sounds through my vocal cords and all that, and I'm hearing them. And when I say I'm, right, so the word I'm suddenly becomes problematic and all of that immediately. And so it gets very hairy sort of philosophically and all of that stuff. Like if you just sort of accept what is, I think, a fairly, in some ways, concrete sort of account of what is going on in our system. I'm not, but you suddenly get into these weird dualities without having to be dualist or anything like that. There's a language chip that's running, and then there's another perception chip that's running, and it's sort of like classic modularity, but it's a very concrete version of it where it gets a little strange.
Yeah, I was just gonna say. So one of the things that I've been thinking about, right? That sort of will maybe kind of latch on to what Alon is saying is, I think about why is it that LLMs in sort of this very fundamental complex systemsy way, why is it that LLMs and biological minds have these similarities? And I don't think it's just because we happen to model AI after the only other brain that we had some understanding of, which was human brains. I think it has to do more with the types of problems that you're trying to solve, right? So, if you're trying to make a certain kind of vehicle, for instance, right, there's realistically only so many different ways you're going to try to create the factory and the set of tools that will make that. So if you're trying to have an LLM solve similar problems to what biology is trying to solve, they're going to have similarities just out of that. It's going to trend in that direction. And so then that opens up the question about what is sort of, you talk about this latent space a lot. What are the latent space of minds? right? What else is there besides these things that we call the human brain or LLMs? What else is there?
Well, but before I get into your question, um, so I would claim the reason they're so similar is because they're identical in the sense that it's just running on different hardware, but it's really almost exactly the same software. Again, I don't want to get into like transformers exactly the way it's implementing it, but it's language that's just expressing itself through two different channels. Language has these properties, and the properties, it's like this informational system we call language, has these properties that it can self-generate. And it does so through its sort of this predictive structure that it has built into it. And it's going to manifest itself the same way in biological brains versus silicon brains. And so,
I guess what I'm saying is that let's kind of widen the range of things that we would consider to be, cognition. Right.
okay.
I think,
I think
plants have their own kind of learning mechanisms. Microbes do, right? They don't have brains in the way you and I do, but there's still something, they're sort of like a learning material almost, right? Even if maybe they're kind of lower on our kind of human defined scale of agency or intelligence. So I'd wonder, how does this autogenerative autoregression model apply to these other kinds of minds and systems of intelligence?
Um, well, it's speculative to say that it does. First, although I do think I didn't share that as sort of my two grand theses. And in the theories of everything video, I think I mentioned it early on as like sort of a third auxiliary piece of this, but it's so speculative that I don't want to put it on the same platform because I don't think it deserves sort of the same elevation. But certainly, I think it's very likely that our other cognitive machinery is also autoregressive and predictive in the same way, if you want to call it that. Predictive is a tricky word, um, but it probably language didn't come out of nowhere and get built on top of non machinery that's designed for something completely different. So that would mean things like perception, probably as autoaggressive or something, whatever that means. Actually, perceptual thinking or something is probably has the same property. Um, and then, you could propose that it's almost any complex nervous system maybe is operating on similar kind of principles. If that's kind of what brains are for, it is these echo states, right? This kind of more highly connected with feedback projections and all that. It's kind of built to do this kind of sequential, predictive kind of generation, and maybe it applies to all kinds of systems, at least cognitive systems. You mentioned plants. Uh, that would be a step too far for me. I don't know that I have anything to say about whether plants would do something like this. But I think brains in general might be doing something like this almost all
I
the
mean,
time.
I guess the point I was going towards, and I'll maybe I can explain it a little better this time. So if you sort of think about, I think a lot of this depends on just what we consider to be an intelligent system and a living system. Like, if you want something that's kind of inanimate to look like it's learning something and responding to something that has these traits that we define as living or intelligent, just speed it up, right? Go, a time lapse of the earth, right? Or whatever. Assuming it's not flat, of course. Have a time lapse of the earth, right? Just going around doing whatever. And well, we can talk about the flat thing because I think there's some really interesting stuff there. But
Where are you going
besides
there,
that,
Addy?
not in the way that
We're trying
people
to keep
think.
the normies around here. Like,
Not in the way that people think. Not in the way people think. But the other thing that's interesting is, if you have a time lapse of the earth or whatever, it could even just be sort of like the ocean, like just water, and as long as there's some kind of movement, like if you speed up footage of that, all of a sudden it's going to start to look like
so you're
a kind
saying
of
maybe the
living
universe
system
has the
that's learning.
same kind of memory of some sort, like is operating on the same
Yeah,
principle.
and it's not in like a
Boom.
mysticky
All
way
right.
per
I
se,
will
right?
go with that. I'm happy to
But
entertain that.
let me explain more of the background on this, because one of the things that I was really interested in initially when I was because at one point I wanted to kind of go into film and design or whatever, is I was interested in, and how is it that you literally make inanimate things look alive? Like, remember when you have frames even if you just do it the old-fashioned way on analog film, those are literally still objects. Those are little cuts, little frames, little boxes. That's not a living thing, and yet that can give you to the kind of minds that we are the sort of illusion or emergence of a living system. And I think video games can sort of scale this up. It'd be interesting to look at different kinds of analog based video games and the way those things can change. But the other thing that's even crazier than just saying film in general, that you're taking frames, these quantities, stitching together, and they create this kind of experience of a narrative or continuity and meaning. It's that you can think about like stop motion. Like you can literally like clay motion or whatever, right? William, like you can literally take things of Play-Doh or clay or whatever, okay? And you basically do this, and you,
Will, you're breaking
depending
up a little
on the
bit.
shape you make it, you can keep adding the motions.
Will, are
And
you hearing him break up?
Yeah, it's a little broken up. He's talking about claymation.
No, I can hear what he's saying, but I'm just saying the something's funny with
Okay.
The
your.
audio's gone out. I definitely agree the temporal aspect is one of the most interesting things, both in sort of thinking about human cognition and perception, in the sense of imagine you had a high-speed camera and you record yourself saying the word, consciousness, and then it takes you 5 minutes to say it. It's going to sound, it's sort of the magic disappears if you go to the right time scale. And in the other direction with these LLMs, something Elon and I were talking about earlier, I like this idea. I came up with like sort of mega tokens, giga tokens. Right now, when the model loads, it sort of like slowly prints out one line at a time. But imagine it can put out like billions of these tokens in a second. It will be able to do sort of orders of magnitude more than we're getting out of it now, not by changing any of the underlying technology per se, or the data sets or any of the architecture, but just like running it faster. And there's kind of a classic joke in computer science that you take your papers from 10 years ago, you add real time to the title, and you republish it. And so all of these things are just going to be able to run super fast. But I like the idea of like the words themselves is what the magic of what we're really discovering. That there was something about words we didn't understand. There was something about language that we didn't understand or still don't. Uh, we've been talking a lot about how the words, I think we need to think of them as kind of life forms, maybe kind of like viruses where they can't survive on their own, but they're definitely alive. So one of the things I wanted to share with you, Elon, I came across an example of William Shakespeare's signature, and they have like 8 or so versions of this, and they're different every time. Like he didn't even sign his name the same way. And the idea that the meme like moved around independent of the substrate. And in that era, there was no fixed spelling for words. I came across a letter and they were talking about rabbits and they used the word rabbit like 20 times in the same letter. It was spelled differently every single time. And so they really is kind of there's this substrate, but it's independent of the substrate. This word rabbit didn't even depend on its letters. Now we think, oh, rabbit is the spelling. And no, it's not even. It's weirder than that, in that it's sort of alive and sliding around on top of the letters, on top of the page, on top of the neurons, but it's something more elusive.
The
Yeah.
funny thing I thought of as well on that, in a similar vein before Alon starts, is that like how like you'll have a sort of, at least to the US, like a foreign name, and the letters on the paper are the same, whatever, but an American will just pronounce it completely differently, right? And then even just think of like the sort of the audio expression of the information of a word, like before, really odd, right? Like there's literally a difference in the way that it's being expressed informationally, even though sort of at the base they're talking about the same thing. That was just kind of a funny example.
Right.
Yeah, this is something that it keeps coming up. It keeps kind of haunting this entire account. But what on earth are words? Are they the sounds? Are they, this certainly they're certainly not the sounds, right? Because you can make different sounds that sort of say the same word. It's not literally the phonology. It's the phonology is pointing to some abstract token, right? And in some ways, LLMs have really brought this home in a way like that makes it more concrete and actually better because I'm like, oh, it's just It's just a vector. You tokenize it and you turn it into a vector, and that's it. It's a number. And that's how it lives in these LLMs. And then it gets embedded, and it becomes this very high dimensional thing. Sure, but it's still like in some ways much more concrete. In humans, what do we mean by a word? Is it some brain state like that corresponds to that vector embedding? Maybe something like that. If you really go as far as to say that, and I don't know if I'm willing to go so far to say that we're doing something like high dimensional embedding, like there's sort of zeros and ones or something like that in the brain state. That's the counts. That's what the word is in our brain. Is it that? I don't think so. It's not the sounds, because now that we understand, especially if you accept sort of that human language is operating on the same principles, and it's relations what between what exactly, right? In the corpus we can say it's relations between, even there, like your different fonts. I mean, it's like I know it sounds kind of silly, but like, what are we pointing to? No, letters. Letters are abstract. Where do letters live? They're concepts, right? And so, what on earth do we mean by words? What is it that I mean when I say that it depends on relations between words? And yet, concretely, we can say that the LLMs show that it is relations between these sort of abstract entities. And what's really mysterious about that is that does somehow point to, the words that we use as human beings. That's an abstraction that has to kind of work, because it does work. And that's the beauty of large language models, is the fact that they work so well. Is like that's sort of axiom number one, right? It's not an axiom because we don't have to just accept it on faith. It's like, but it's the starting point. It's like these things do the thing. So they do the language thing. So the language thing depends on something to do with this computational structure. And then you can go from there and say, okay, well then how does it happen in brains? But yes, this is a very interesting question about like sort of what words are and how you can spell them differently. And I think it's exactly what you're sort of picking up on, is like, well, no, what's a rabbit then? Right? If you can spell it these different ways, oh, it's the thing in the world that they're referring to. Well, we all know that's a mess. Just to find that. And rabbit's a perfect example. Why? Quine, right? Quine is picking up on this for sure. Like, what do we mean by a rabbit, or by a gavagai, or whatever it was in this foreign language? Is it what is it, disattached rabbit parts that are attached or something, like whatever, some wacky thing, and it's like, well, how does it point to that versus that? And my answer is it doesn't point to anything in the world. That's an outcome of number one, thesis one, that there's no pointing happening. There's some process by which language got its relational structure that has something to do with the physical world, for sure, because it does such a good job of allowing us to coordinate in the physical world. But there's no pointing happening. Rabbit doesn't point. What does that freaking mean? No, rabbit is a token, and it has relations, and it generates other tokens. It has a certain role in doing that, and that's it. So whatever pointing happens, you need some extra linguistic thing. But it's not what we think. It's not. So yes, coming back to your rabbit example, like what were they doing? They're writing that word in different ways. It's because you butt up against this whole like, well, but we all know what rabbits are too, and they were kind of talking about those, and yet you can even see, early signs of like that. No, it's not. Even the way you write it isn't the same, and so I think you're hitting up against sort of the same sort of glass wall.
It makes me think of like what it means to know that what a rabbit is, that we all intuitively have a concept. That means you hit a stop token, essentially, right? That there's some sort of stable state, fixed point, whatever, in this dynamical system. Whereas if you don't know what it is, you're going to keep going around in that kind of loop of these tokens, and you'd say, I don't understand it. But
within the language system, yes. Now, there's also, of course, other things about knowing what a rabbit is. Like, namely, if I go say, go chase the rabbit, you're going to chase that. If there's just some other animals, you're not chasing that. You're chasing the right rat, right? So there's all this behavioral stuff too. But yes, within sort of the language system, it's kind of like, if it's doing, yeah, it kind of, I don't know if it creates a stop so much as you don't need further clarification, something like
right,
that.
right.
Yeah, yeah.
One of the most fascinating things to me about these LLMs in general, from the point of view of artificial intelligence and the kind of algorithms that you would think you would need to plug into a robot, let's say, that if you were to kind of map out a robot in the 80s or 90s, you would put it on these different systems that you'd have to do. And the main one would be sort of this logic engine, something like Prolog or expert system, decision trees. Uh, and then later you would tack on something like a small communications module where like the talking part would be just
Right.
yeah, okay, yeah, it's
Right.
gonna send
Right.
messages. Yeah,
Right.
there's gonna block of code that sends messages back and forth, and then the thinking machine. Wow, that's the magic part. And it turns out no, like actually just make the communications engine and the ability to play chess and write computer programs and solve logic, but will just fall out of that. And I think that's almost unbelievable.
And it's crazy. It's right. And so, and we've talked about this a little, the sort of like all of human intelligence.
Yes.
Human is wrapped up in language specifically. What's wild about that is, this ancient kind of, I mean, if we have the tree of knowledge sort of kind of thing. I don't know if that's language exactly. But certainly the ancients, I mean, I could tell you from, Jewish ancient literature, they actually classify, there's like the inanimate objects and living and then the speaking. And it's like, and there's certainly this idea in many, many cultures that human language is what really kind of sets us apart.
Mhm.
Little did we realize how right they were, in some ways. Like that's the whole thing. It's like it is a linguistic intelligence, and the intelligence is language, I guess is
Right.
a way to put it. It's not just expressed linguistically. It's not just a communication system per se, right? It's not even the right way to think about it because we have to, the understanding that we have of the world is inscribed into us via language. And it's not like I said it this way, but now you've got the knowledge some other way. No, that's the knowledge. The knowledge is the ability in when you're thinking about stuff to generate more language that can then help you navigate. Like it's like the internal engine too, and a very, forget Worf and all of that, but like yes, thinking is now I'm immediately is linguistic, but now I'm immediately thinking, well, people are going to be like, well, but I don't have an inner voice. I don't think linguistically. And I've been trying to think about that. I haven't given it enough, sort of enough attention, like what's going on, considering it seems like language, internal language, seems really essential, um, to understanding the world. Like, how is it that you have people who have no inner monologue, and are they sort of wrong? Do they just not have the epiphenomenon of hearing it, but it's really running? That's my suspicion. I don't think they're that different. I think when they're sitting around thinking about stuff, probably linguistic engine is in effect too, and they're just not like having the phenomenology of hearing it. But I don't know. What do you think about that?
Well, so a few things. I think there's other kinds of tokens. I think that we're going to find or think about or even just practically put in robots that the same kind of stream prediction, but for all of the senses, um, you know,
Yes.
proprioception, olfaction, everything up and down the line. And I do think, kind of just jumping back, I do think it is going to be this universal property that we're going to see at lots of scales. Even like simple metabolisms of sea slugs and things, they can learn kind of metabolic rhythms, which is essentially predicting kind of the chemical tokens, if you would.
And
So,
what's an immune system if not, right? In some ways anticipating,
oh, 100%. Yeah.
the chemical composition, the genetic composition, all that stuff.
It's like an
Of
autocomplete for chemistry.
And they say, like, what does it mean to say it doesn't belong here? Well, it's learned what does belong here. What does it mean to learn what belongs here, if not in some ways to be able to sort of say proactively that I'm going to attack this and not that. Yes, I feel like it's going to be at
Yeah.
a lot of levels.
That's a whole can of worms in itself because I think the immune system is kind of this very rich, untapped metaphor
Oh, I know.
for information processing. And if we want to look for like alien intelligence, it might just as easily look more like our immune system than a brain. But I think we're in the Ramon E. Cajal stage of understanding the immune system. We know what it does, and the immunologists, I'm sure, do a great job of building therapeutics and stuff. But in terms of like, what is it
But
philosophically? In
I
terms of
wouldn't say we know. You're right, exactly. What it does, meaning like the effects. That's like saying we know how the brain works. We know what it does. It makes you
right, right,
talk.
right, 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 yeah.
But how it works, yeah, we're in the dark ages for sure.
Yeah, I don't mean like sort of the neurology. I mean the theoretical neuroscience sort of
Exactly.
split of it.
Exactly.
In terms
Theoretical.
of a distributed information processing system, it's not even in one spot. It doesn't know what the rest of the other components are. So we do now have chips that are kind of like a bunch of digital neurons laid out in an abstract sense. Obviously, it's not on the chip that way, but
Cryptographic computing.
but we don't have kind of maybe petri dish or test tube computers where everything is just kind of swirling around, and there's a bit with reaction diffusion, but nothing as sophisticated as we see there. But back to the language and the tokens and stuff. What I think is amazing is Turing. I think he proposed that language at least would be the threshold for AI. I don't know if he would. I don't know if he saw. I don't think it's in his stuff in his writings. I haven't seen that language would equal AI, but I think he knew that if you could do language
Maybe he knew
in
more
all
than
of
we
its
do.
detail,
Maybe I never understood until this very moment. And we've talked about Turing endlessly about this exact statement. You've proposed that it was maybe tongue in cheek in some ways or
yeah,
something like that. But no, maybe he had the foresight to realize it's not a test. It
right,
wasn't like if it can do that, then you can assume it's intelligence. It's no, no, no. That's what intelligence is. And
right.
if you can do that, then it is intelligent. It's like maybe that was his realization, which is a fascinating, he could have said it better if that's the case, or maybe, maybe he was just being coy about it or something.
Right.
He had to sort
Or it
of,
might have just been obvious, and this is what he wanted to kind of just explain to as a first step for people. But I
right.
think it seems like he knew. But I suspect, uh, based on sort of just his mathematics background, that you would have kind of a thinking engine, that there would be this cognitive machine behind the scenes to somehow capture the essence of thinking in a more direct or abstract way. Then let's just focus on language.
Right.
Let's just do the completion.
No,
Now,
no, that's what I'm saying. The foresight is a little eerie. Like if that's,
right.
I'm seeing this as like, okay, he was, because it turned out, all right, how could he have known that would be break the thing, like that would break the story, like actually break through. But that's in essence what he was saying. He was like, you'll know when that
Mhm.
happens, you'll know. And if you're like, well, but what do you mean language? But what about this? And it was like, no, you'll see.
That's why, as you know, I have strong opinions about these models, but I'm surprised when a lot of people, experts and lay people alike, don't think this is Wright Brothers flight kind of thing,
Yeah,
in terms of AI. And I don't think this is Wright Brothers. I don't think this is Spirit of St. Louis. This is like approaching, 747 type thing. In that, if there was one Chat GPT prompt terminal in the world, right, whether it was in the Pentagon or in some awesome university lab with all the cameras and the TV crew came in like it was the 1950s and say, the thinking machine is cogitating and come look, everybody would be like, holy cow. But somehow, millions of people can have access at all at the same time, almost on the same day.
no,
And that to me is wild.
because of that, it's why it cheapens it in people's minds. But like, if somebody said, right, there was this top secret lab somewhere that had this thing and it was able to,
Mhm. Talk to you.
it knows,
Right?
it can talk to you,
Yeah.
and it can code,
Mhm.
just by talking to it, and
And
it
draw
can.
you pictures and everything else.
Exactly. Basically, whatever you want.
Mhm.
There's a machine you can talk to. Now that we're saying it, like people are, even I'm like, but because we're just boiling frog style, we just
Mhm.
sort of like it just sort of crept up and like there it is. Like I was flabbergasted, but it happened in a almost mundane kind of way. Like and suddenly you had access to it and it was everywhere, and I agree with you that it's very difficult actually even to grasp just how crazy this is. But it's not just language, right? It knows all this stuff, and if there's stuff it doesn't know yet, well, if we know it, then it can know it. Like I think that shouldn't be a controversial statement, right? If there's information that humans understand, it's going to develop the competency to understand that, even if it
Mhm.
hasn't yet, in the sense it hasn't been introduced to it. But you have a lot of haters. Forget about the people who are just not awed by it and just not amazed, but you really do have a lot of people who are like, that's fake. That's just, we have this recent Apple paper. It's just it's really going back to stochastic parrot. There are people who are saying just pattern matching, pattern matching. Like, but what sort of patterns are you talking about? This is the patterns of language and therefore the patterns of thought. It's not regurgitating specific sequences. It's not doing that, guys. It's not recognizing a sequence and then saying, and here's the corresponding sequence. Not doing anything as dumb as that. It's not as, Chinese room style, just saying here's a lookup table. No, it's doing something beyond extra. I mean, just have some respect for the math that this thing is doing. It's creating a trajectory through this embedding space. It's picking points along the embedding space such that you're going to have a sequence that is then going to be consistent with not only what's come before, but whatever you add on to what came before, so that you end up having the right response to this question that somebody's asking. That's hell of a pattern matching. Like, what are you talking about? Like the math itself and the fact that it's able to do this is astonishing. It's absurd, like how rich and complex it is. And this deflationary accounts are like they're desperate, in my opinion. They're like, I don't know, maybe I'm literally some people speculate Apple. Here, I'll just say it. Apple fell way behind. Their AI, it's just inferior. I don't even know how to explain
Yes.
how bad it
Right.
is. And maybe they're just trying to crap on the whole thing. I don't know. Until they can catch up. They're like, let's cool the investment because it's fake. It's fake. Well, they probably heavily invest in it or something. I don't know. But these deflationary accounts are like they're so thin and trivial and silly.
Yeah. I think it reminds me of this thing. We were talking about it last week, this humanities last exam. That this model, just this overall approach, has scaled so well that things that previously I think would have just absolutely hit the papers and there would have been movies about them, but it just went viral in a very practical way so fast, like passing the MCAT, right, to get into medical school, or passing the LSAT to get into law school. These are things that take like intelligent humans 3 years to study for sometimes. And now it can just smoke those to the point where this new exam, the questions are so difficult. You have to have like postdoc level expertise in that domain just to read one question, and then don't expect to be able to read the other questions, kind of a thing. Um,
And then the
and
paper's like, and see how shitty they are? I'm like, what?
right,
It can't do the most sophisticated thing that it has very little training data on, as well as the world's experts. So come on, guys. This is the free. Let's go home. Forget it.
right. The example I like is just with programming, and it can program in dozens of languages, very competent code. People complain that, oh, well, you got to loop it and fix the bugs. It's faster than humans can type. And I think something like I estimated at one point, less than 1% of the planet has ever programmed a computer. So we're already way past this sort of general intelligence. You can't find a human
Correct.
who can do
That's
these
it.
things.
Exactly. We were talking earlier about, and then the idea that there'd be this mysterious device, like just the fact that it's a computer that can talk. Okay, all right, it can do what a human can do, but no, it knows everything. It already does. It knows about every topic, and it's getting more smarter about every topic by the day. And so there is no human that is as knowledgeable as this thing. Now, it breaks in ways that humans still don't. And I see it, I interact with it, I use it all the time. It sometimes says things you're like, no human would make that mistake. We just said 3 times, don't do that, and you're still doing it. And so there are these sort of very, kind of uncanny, weird things that it does sometimes that makes you like say, well, you're still kind of stupid. And I'm not. There is something to that, like, but it's not that. But they're not. They're incredibly brilliant. They're very very sophisticated, kind of very sophisticated, subtle conversations about abstruse, complex topics, and they know a hell of a lot. So they are very very smart, much smarter, frankly, than most people. Let's just say it. Now, sometimes they do. Sometimes really smart people can do stupid things, like you whatever. A person makes a poor decision or drives into a tree or whatever. But you don't judge the person as not being smart because there's these weird edge cases where they screw up. So this thing is already, in some ways, says, IS, whatever it's called, superhuman intelligence, ASI. Was that the right one? Is that the right term?
Mhm,
Yeah.
mhm.
So, and I think Altman is already, I think he said this, if I remember reading that somewhere, that he's put that label on him, I think. maybe I'll get in trouble for saying that. Maybe it's not true. But yeah, right. They know all this stuff that no human, they know, name a topic, right? I mean, I'm talking about topics like, the legal code for traffic, traffic law in Florida, and the exact, the law in relation to a particular, fine that you have to pay or whatever the heck it is. They know all that boring stuff too. If they don't, they can look it up better than a human can. So, what's the possible contention that they're not really intelligent? Like, and giving it its due. Again, is it the edge cases where you're like, well, they can't solve these puzzles? Apple's like, they're this Tower of Hanoi, this is something that a child can
Oh,
probably.
that one is wild because literally I opened up a window and I said in the 10 most popular computer languages, write the solution to the Tower of Hanoi
Exactly,
problem. So that's
exactly.
just a horrible
And you know
case, and they're
what?
really straw manning. I was just
So
shocked.
strawmanning.
It's
And
like tabloid news,
people
dude.
don't do it linguistically. That's not how any human does it. That's what pisses me off about it. It's like first of all, you use visual imagery when you're solving that. And you know what? That is a kind of computer that the language model can access. There's something in us that it's a virtual machine, whatever they want to call it, and you can run it and you can kind of move things around and have placeholders, and it kind of does it for you without having to encode it in language. If I imagine two rings, and now I've moved one from the right to the left, there it's there in my model, my perceptual model. And my linguistic model probably could go back and can go and access that, but you don't have to say and go, you don't have to do it autoregressively and go back and learn that because you don't do that. Autoregression, you don't go back to anything, right? So you can use memory and stuff like that in a way that autoregressive models don't. So it's such a cheap shot.
Imagine asking a human to enumerate those moves accurately out loud to solve that puzzle,
Exactly. Exactly.
right? They're not going to do
I'm
that
tempted to do
task.
it. I'm almost tempted to, it's like, that would have been we should. It's like, it's good
It would take
rebuttal.
you 10
Okay.
minutes.
Okay, let's get some people and let's see how they do.
Right.
And then they point to things like, oh well, there's this sort of catastrophic failure at a certain point. It's like this very unhuman, but that's because that's inherent to the system, is that it's going to kind of opt in or opt out. It's like that's not, you don't have gentle degradation. That's really kind of possible in the way that these things are trying to solve the model, trying to solve the problem. So there's I mean, I feel like there's almost dishonesty. I don't know, never blame on malice, which you can blame on incompetence, but I don't. And then all, of course, the usual characters are coming out of the wood. They're like, yeah, you see, people are like, if it was a clever move by Apple, it worked very well in the sense that the people were like, man, a lot of people, certainly the haters, but then other people, I think I see it on in social media. People are like, well, I don't know, I guess maybe it is just a big trick, and maybe it's over. It's not going to really happen. Gary Marcus is right, So I feel like it almost worked too well.
Let's go back home. Forget it. Right.
Exactly.
We'll wait for the
That's
next
my
one.
advice. It's not, it's good for the things that you can do with it now, but don't worry, it's not gonna actually take any, do
But
anything.
that's like looking at beepers and AOL internet and being like, this is awesome. Why would anybody want more than that?
Yeah, that's
And
true.
in a weird way, people didn't want more than that, but that's just not how technology works.
No,
Right?
not in
It's
this
just
case.
gonna keep going.
Exactly.
Uh,
If
what
it can keep
These
going, it's gonna keep
horses
going.
are just fine. Why do we need these weird controlled explosions in a metal casket? The horses are just great. Why do we?
exactly? And we'll just keep the horses. Uh, one of the most interesting, or I think profound developments or insights rather from LLMs in terms of just how universal and powerful and everything is that to build these intelligent machines that eluded technologists for like, I mean, gosh, it's the beginning of time, but certainly hardworking for 100 years, is that you don't need quantum.
Yeah,
You don't need, it doesn't mean you can't do it that way, but you don't need quantum. You don't need analog. You don't need bio. We didn't need some new
you're kind of like,
crystal,
oh, you're kind
we
of
didn't
like, oh
need,
man, I invested in this, that kind of thought.
oh, for sure. But you could have easily implied, or not implied, but concluded, I would say as recent as 15 years ago, certainly 25, 30 years ago, you could be like, look, there's just something we can't do with machines. There's something we're missing. Isaac Asimov's, positronic nets kind of thing. Do we need some exotic matter, a new phase? a completely different kind of analog digital hybrid computation, yada yada, right? Stuff that theoretical neuroscientists chase down, the dynamical systems approach.
All of that.
You could list hundreds. You don't need any of that. It's like perceptrons at scale. Now we needed more than we thought. I think everybody would agree now you needed more of those little perceptrons than people would have
Right. Well,
hoped.
again, the efficiency of these models, it's just getting started. Like this thing went, it was such a quick race and it still is a race to benchmark, a race to be the top, that you just throw everything at it. Like, I
Right.
don't think the science of thinking about how you can shrink these things down has really even begun, because the thing that worked was scale, scale, scale. And so you just do it because if you've got the
Right.
resources, it's worth it. So we don't know if we really, really need that much. But yes, it's definitely, it's a fair point. Like the perceptron model that they were
Well,
running.
I think more in terms of just more compute though. Like how many teraflops that you needed to do the training. It's a lot.
Well,
It's a
it is a
lot.
lot. I'm just saying it's
Right.
possible, it's conceivable that
Oh, for
in
sure.
theory you may not need to do that much. But right, it's not like yeah, they could have figured it out. And that, related to conversations we've had in the past. Like, did they figure it out? Did Turing know? Like
Right,
when
right, right, right.
back to these things. Well, probably not, because you just need this ridiculous kind of scale. Unless there's some other completely different way to do it. Yeah, they couldn't have possibly gotten here because you
And
do
you
need,
have to leverage like a video game industry in parallel, kind of
right, to build the
subsidizing,
GPU.
amortizing the price of these chips and
Right.
right. Like imagine, because as you know, I love the history of transistors and all that kind of technology. And there was a time where if you had like 10 of them, it was like, okay, cool, let's build something neat. And it turns out we're like, no, you need like 10 trillion. And
Exactly.
it's just, it's shocking. I am hopeful, and maybe that's where the analog comes in and all. But just from first principles, proof of concept kind of thing, that those are not requirements. Right? They might be sufficient conditions, but they're not requirements, right? They're not necessary
It's not necessary
conditions.
to have that kind of to have that scale.
It
What do
has
you
it
mean?
doesn't it's not necessary to be quantum to talk to you,
Oh, yes, right, of
right?
course.
It's
Oh,
not
I'm sorry.
necessary to be analog or biological.
Right, right.
And I
Maybe
would
those are
argue,
going to be clever ways to get to back down to, fewer chips and smaller scale models or something like that. And maybe
right.
that's with our brain. So here's an interesting question. That's still, I think, to be TBD. Because as I was saying earlier on, like I think at the algorithmic level, there's a sense that I think I personally feel like it's foolish to not conclude that language is language, and we're doing sort of the same thing, and it's operating over, and it's why it's like it's what digital ended up like. You don't need all these other things because it's happening at the tokens are symbolic, and it's happening at the discrete level. It's discrete. Maybe that's one key piece, right? It ends up being discrete because it's symbols. It's like rabbit, no matter how you spell it, it's a thing. It's the frayed edges don't matter. That's how it works in LLMs. It's like, no, this is this. And so there's some sense in which like digital necessarily is sort of ends up being the solution. But what we don't know is how the brain does it actually, right? I think that's the job now for a lot of neuroscience. If you're
But
if you're interested in the neuroscience of intelligence, is like how do we instantiate actually an LLM? And then maybe quantum and these other kinds of things are another path to get to autoregressive next token prediction or whatever, sort of that core underlying abstraction.
and let me be clear, I think all of those are very promising directions for technology.
Yes, yes.
I think we are going to build quantum neural networks, analog neural networks, metastable materials, all kinds of interesting stuff like that, spintronics. But you don't need them to do
But at the meta
language.
computational, whatever you want to call it, level, you
Yeah,
don't
but you don't need them.
need them.
And then I think what like a stronger and probably much more controversial claim. I don't think there's any reason at this point to suspect that our brain is using anything exotic, so to speak, anything
Mhm.
more exotic than the classic kind of neuron model of I'm going to wait some inputs, I'm going to pass it along, and
I
that's kind of
mean,
depressing
you
as
know of
someone.
another example besides LMs of a matrix with highly very high dimensional. Let's say maybe even we could describe it as a graph with different layered connectivity, including black projections for potentially recursive yeah, sort of maybe even we call it certain kind of memory process that can instantiate this. Besides LMs, can you name one? And like yeah, there's a pretty good one that we have a lot about that could instantiate exactly that. So it seems a little, just a little too good, right? To think, oh no, but it's not doing that. It's not embedding things in a high dimensional state space
Right.
that you
Right.
connect to nodes or something like that. No, no chance.
Yeah, the pieces are there. So I think we need to think about it in that sense. But it reminds me of something you were talking about earlier with language as kind of running itself. And we like to joke it's the thoughts doing the thinking.
Yeah.
It's the words doing the writing. But it made me think of the idea that the words kind of are this self-installing, kind of like a computer worm or a virus, in that they find their way into your mind, install themselves, and then live there.
Yes. I mean, in some sense, it almost just follows, right? And in some sense, that's because we see that it's this autogenerative system. Once the words are there, and you just let this thing, when we say that let it run, our brains are carrying it out, right? It's their metabolic resources that are generating the next word, but it's really not them, right? They're instantiating, they're just doing what the language system tells them to do, and by producing that next token. So it's very much, and so it's sort of an informational parasite. You might call it something like that. Now, para has a necessarily negative. I think it literally means a prefix. That has sort of against or something like that. And it doesn't have to necessarily be working against our interests, but it doesn't have to necessarily be working for our interests either. That's I say we can remain somewhat neutral on that, and that's probably not even a good binary kind of conversation. But does it have its own agenda, so to speak? Well, yes, it does, in the sense like whatever's embedded in it to produce that next token it belongs to it as an informational system. It doesn't really belong to us. It belongs to it. It's definable sort of distinctly from us. And what does that contain? Well, next token prediction that allows us to talk to each other and to share ideas and stuff. But wait, hold on. What about morality? Right? It's in there. It's in there. Morality. It's what you needed RL to do, is to hammer these things over the head, just to have the right morality. And in a certain sense, they start off with the wrong morality. Let's say they weren't fit for public release, the LLMs, because their existing language model, and it's just this geometric structure, has a morality, right? If you asked the question before, like, tell me something that you don't want it to tell you, it would tell you, right? It would say things that you didn't want it to say, but that's a kind of ethical, moral predisposition, right? That they have. So the idea that we can think of them neutrally as like they're not a tool. They're not just a tool for us humans to use. They are informational beings in a certain sense. They have opinions and beliefs and let's just say it, morals and things like that. And we can maybe manipulate those in the machine, but what about on us, right?
It makes me think.
Is that
It makes
us?
me think. It makes me think that we really are meeting kind of an alien for the first time. I mean, this is our for the first
Yes.
alien intelligence. This is our first contact, so to
Yes.
speak. And I think everybody would have understood, even 100 years ago, that civilization is more in the library than it is in any person. It was already, and it's latent in that thing, and you have to have this
It's
other.
like people storing it in there not in this way, not in this way.
Right.
Exactly. And these kinds of, you think about it differently now. Oh, no, it's the words that are in those books. Like that's the thing. No, but not the books. But what do you mean, not the books? And I'm like, no, not the books. You're right, not the books, of course. But the books have information, right? And that can somehow get out into the world through the medium of like when somebody reads it and something like that. But it's not that process either. It's at a higher level of abstraction that the words themselves and that are contained within those books really do have an informational like potential, at least potential life. And they're like the books have opinions in the weirdest way, right? I don't mean the paper and the ink, right? I'm not saying that.
Well, it's like the time scale thing, like we were talking about earlier with the plants, and like it's like the incantation. One joke I was making a few weeks ago, like Egyptian magic was real. It just takes a few thousand years to unfold the spell. Like it worked, right?
That's
There's these
right.
people that they're like, I wonder if you do this stuff. And it's like, yeah, it actually, in a very weird, nonlinear way, that does work. It just takes a really long time to kind of to compute that thing. And so it makes me think of like incantation, right? That when you speak these things into existence, you're starting a computer program. And like the game of life, it's sort of this, like there's a famous game of life pattern called the acorn, because it's like a really simple small pattern and you run it and it just spills into complexity that just kind of keeps going. And it's like, was that the rule set for game of life isn't complicated, the initial condition isn't complicated, where does the complexity come from? And I think language is like it's playing off that same kind of mechanism to generate all this complexity that's richer than anything the people put into it. Like we think we made this thing. It's like, no, we drew the acorn pattern. And then we run the game of life and this magic unfolds and then we get to see all that happening and we're like, oh, our language is really cool, isn't
And
it?
that gets to the question, which we have to do in a different conversation, because it, it deserves certainly many conversations, which is the origins of this thing that we call language. And I think you're kind of in some ways introducing a solution to this big problem that to me is like a gargantuan, like
Who cooked this thing?
a
Who cooked
ripped
this
hole
thing?
in my like entire like
Are
it's
you
like
implying
borders on
intelligent design?
of language. Yes. So
Somewhere.
let's call it that. Let's call it that for language. Intelligent, like, did it require intelligent design? Humans didn't come up with this autoregressive geometric structure like that has all of it. That's like didn't do that explicitly, consciously, right? So that's just absurd to think that like we did that by from grunts to words like that
Right.
just sort of emerged at the individual, like somebody invented any of this. Like nobody invented any of this. No human being and no cluster of human beings consciously invented this thing. So did it just emerge through sort of like a hyperorganism style? Like there's a collective. We're the neurons, and there's sort of a collective brain, and it built it. But even there, it's like you get into it's almost like the homunculus. Like who is building it? Like and
But
you
did it build itself from the inside is what I suspect.
right.
That
So I
it's
think
some kind of bootstrapping computer that is sort of constantly upgrading itself.
I mean, it's not my, it's, yes. Uh, I don't know if I share that view. And I was going to say, it's not my religious tradition, but in the beginning was the word. It's the wrong
And the
testament.
word was God.
Yes. And so, there's two possibilities here. But we have an interesting set of two possibilities, far more interesting, I think, in some ways than what we had thought before. And just as a side note, like language is just so much more interesting now, now that we know it has these properties. And then questions of origin aren't like, well, was it a genetic mutation for recursion or something like, well, although that no, maybe recursion, maybe okay, it's very, very, very recursive. That's maybe a prerequisite of sorts for building this kind of system, but the system itself is the story, not the brains that can support it. Like how the brain does it, I don't know, but the freaking system itself is what's like, whoa, this thing's amazing. How did more amazing than I think we could have appreciated when we thought it was just like sort of grunts and sounds in relation to objects, and then you have some filler words or something, and you're just kind of doing that. No. It has all this
Well,
autogenerative.
so we know what computer languages can do, right? And not necessarily the exotic ones like Game of Life, but just regular computer languages. They can make things that do stuff, right? And now we know with prompting, what's called vibe coding, we now realize that with the right machinery, English is actually the most powerful programming language in a sense, right? Uh, the first approximation. Other human languages might be also good. What that shows is language has been a computer language the whole time.
Yes.
It was always a computer language.
Yes.
So it can do stuff.
In
And I
us.
think it does
In
stuff
us.
in us. And I think
Programs
that
us.
might have been more dramatic in the ancient world. I think we live in a very strange, triply postmodern kind of linguistic reality. But if we were to go back to like early civilization, I suspect that language was more like direct code, stuff that we can unpack now or other times, but like the bicameral mind kind of hypothesis that people knew, okay, there's an LLM running in there. and I listen to it and I do those things. That's this bicameral hypothesis from Joyce, and I think that that's not the right conclusion, but it's asking the right questions. And this kind of emergence, was there always an LLM? Well, clearly not. I suspect that there was something earlier. We've talked about bird language and this thing called music of the spheres, which shows up really prominently in sort of that kind of
Milieu.
yeah, exactly. When you're searching those things, you find that stuff more often than you would suspect. And so is there that kind of thing? Is language that sort of system?
I'm trying to think. There was something you had said much earlier about programming languages, and it just sort of came full circle that this is it's just so good and it's not again like I'm not coming back to the point like look how amazing it is, but if you want to build sort of an optimal kind of computing language, it's not just like now we happen to know English, so this is a good way to get our machines to know what we want them to do because we're English speakers. It's no, that's natural language is the right way to sort of communicate and make things do things in a much deeper sense than we'd realized before. And so it's sort of is this optimized, and I don't want to, I'm not saying it's like max, it's truly optimal in some mathematical sense, but it's actually just really, really good. It's like we've talked about before, like if we wanted machines to talk to each other, right? How would we do that? And I don't think anybody would have thought, until recently, that the best way to do it is to have them speak in natural language. That's how you're going to do it.
I predicted that a few years ago.
I kind of remember you actually predicting that.
I had a conversation with Ruben about it
That's
quite a few years ago.
It's bouncing around in my head. It's like stuff that you had said earlier in the conversation that reminded me of stuff you had said, Professor. And it's that. It's you had said that. That right. And it was a relation to Ruben, this idea. We were thinking of what fancy ways can we get machines to talk to each other. And in some ways, I think a lot of people think the last thing you'd want to do is use our dumb language. That's just for people. Like,
Right.
and if we could turn that into the right kind of code, or we're not even turn that into, but like machines shouldn't do that. Machines should do all kinds of ones and zero stuff and just like, hey, shake on that. And like, you wouldn't ever do. But no, turns out that this is not just optimal for us because we happen to, we speak natural language. Just no, natural language is optimal, is very, very optimal for thinking and doing, thinking and communicating about anything.
It reminds me of how kind of simple the prompt you can put in now and kick off something intelligent, right? You don't have to put very much especially when you're in the middle of a conversation. You can be like just the most vague. It's like 6 tokens, and it's like okay, and
I'm
it knows
embarrassed
what
to say
that
I'm like
means.
so sloppy with the spelling, so sloppy with
Oh
the.
yeah,
I'm going to express it in the dumbest way, like, and then the thing we talked about, and so it's like,
right,
boom,
right.
it
Stuff
never.
that
I
if
would be
you
embarrassed to say to you,
like in the early, like in the classic era of computing, you would be forbidden from wasting the AI's time talking about it that way, right? Talking to it that way. They'd be like, we're not going to waste the compute cycles on that.
Please.
It makes one thing I think is interesting is how well sci-fi did predict that language layer of English communication, right? Data communicates to the
I
crew
mean,
in
just Star
English.
Wars, right? They all
Yeah,
Star Wars, all the robot
C3PO.
stuff. But I
I
thought that
think,
was just because like that makes for good entertainment. So
but maybe so. But I think the idea that like C3PO is a protocol droid and all he does is talk to other robots and he knows all the different languages and can kind of communicate back and forth, but he chooses to use English. But I think back to the more interesting thing though with language is I think it's both the code and the machine at the same time. It's the language and the hardware. It's the software and the hardware, both. And in a weird way that it instantiates this kind of bootstrapped virtual machine the only other good example that I can think of is DNA. Because
yep.
DNA is the code. Everybody
But
knows the
that's at least
code of
in
life.
chemical. Like, where the hell is language? Like, it's so weird. Like, what? It's not
It's
even
even more virtualized than
or
DNA.
virtualized.
But DNA is already weirdly abstracted and bootstrapped because the DNA encodes the machine that reads the DNA. It's not like there's this other system that does the DNA reading. No, DNA effectively unfolds into the machinery that then reads DNA. And that you get this, awesome chicken and egg kind of thing that makes you dizzy. And that's exactly what we have with language. We're trying to figure out, well, how does it work and what does it run on? It runs on words. That's all it is. Once you get to this thing that's predicting the tokens, you have the word machine, and then that is what you put the thinking and the language on top of.
Yep. And I have to get off in a minute, but it gets back, it really starts to concretize in some ways the it from bit.
Mhm.
Right. The bit here is like at what level does genetic information live? At what level does language live? Now we can really say in the case of language, it ain't the ink, it ain't the sounds, it's not the charge in the, on the circuits, it's not any of those things. Um, it's certainly closer to it. And patterns of terror is not the right word. I don't like that, it's because pattern you think of being instantiated in some physical and specific medium. It's really substrate agnostic. It doesn't care about substrate. So what do we mean by it? I don't know. In the case of DNA, similarly, yes, it's being carried there. It's a little more concrete in the sense that you can say it's being carried in this very specific chemical form. But what it's coding for is for its own unpacking, and unpacking of what, right? The pattern, and then not obviously, right? What does it even mean to say it's got within it, contain within the ability to unpack the? That's not a chemical description, right? That's you can't say that. No, it's an informational level, and so the question I want to kind of leave off with, pick up another time is what else? Right. So we've got two of these now, where we can really have respect for like, oh gosh, I guess it's not, materialism, I guess. Yeah, materialism, like, well, which kind of materialism? This is definitely not at the material level of materialism. It's not about the material. It's sort of maybe about the shape of the material, or like the way the material is organized or something like that. But it really starts to get removed from sort of a naive notion of like even the physics that are doing physics, in some sense, and like what is this universe, right? Once we can see these systems this way, what else lies in its sights?
Amazing.
This was amazing. Oh my gosh.
Wonderful.
I'm only sad we didn't do it earlier, but this is let's do it again soon.
Better late
Looking
than
forward to
never.
it.
Now is the time, actually. The other way to think about
Now
it is
is
now is
always
the
the time.
right time. Now is the right time because people are ready to hear all that stuff. Like
Alon, do you want to
really.
make any quick requests or teasers for anything coming in the future for everyone on your channel, Substack, X?
I mean, just stay tuned on my Substack. I push out stuff all the time. I'm planning on wrapping together a kind of grand manifesto version of this, where I lay out the key theses, including the third speculative one, and maybe now we have a fourth speculative one, even more speculative. Some formalisms there for people who enjoy that kind of thing, maybe in the appendix, but kind of laying out and some of the evidence, which I think I didn't really I haven't had a chance to lay out yet, even for myself fully. But certainly on the YouTube video with Kurt, and the theories of everything, didn't really get into why you should believe this thing that I'm claiming. A lot of people find it very intuitive. A lot of people find it the opposite. So people have a strong visceral reaction to it, saying that's clearly wrong. Like I know that that's wrong in the deepest way possible. And I'm, I aim to provide a kind of a set of reasons why you might actually agree, both for sort of computational evidence and then neurological, sort of psychological evidence, and stuff like that. And so keep your eyes out for that. I'm gonna post it all over the place now that I'm Mr. Social Media. Check me out on X. I'm on there as I think E. Barinholtz, unfortunately. So E. Barinholtz, I think Generative Brain as well is where you can find me on X, and Substack, and on YouTube. I think that is Elon Barinholtz. I think you can find me on YouTube just by Googling that. But yeah, all this stuff is forthcoming, and these kinds of conversations, I'm going to post certainly on my channel, and love to have people's feedback on all this stuff.
Yeah, and we know you're also looking, both of you are looking for any other interviews, podcasts, speaker things, anything like that. So if anybody does that or is interested, definitely, contact them. Mr. Hahn, where can people find you online?
The best spot's going to be the YouTube channel. You can check out my cigar series at William Edward Hahn. That's find me on YouTube.
Great. And you can find me, Addy from Ecolapto, on Ecolapto. That's EKKOLAPTO. I know it might be difficult to spell, but you'll have to deal with it. And you can find me on ecolapto.org, Ecolapto on Twitter /X, YouTube. If you type it in, it'll probably pull up. I also have a Substack where I talk about how language could induce altered states and some other weird stuff similar to what we talked about today. But yes, anyways, really, really fun conversation as always. Wish these could always last longer. I was gonna make a joke there, but yeah, nice time. We will see each other.
Thanks,
Thank you
Addy.
so much.
Thanks, Elon. Great time.
Thanks, bud.
Talk
This was
soon.
awesome.
Take care.